Okay, so we're graphing rational functions. We last week looked at rational functions in standard form, so we had y equals 1 over x minus h plus k, correct? Okay, h was the left and right movement of the vertical asymptote, correct? K was the up and down movement of the horizontal asymptote. But not all rational functions are written in standard form. So what we are going to do is there's a specific kind, or when rational functions meet specific requirements, you can use long division to put it into standard form. And those requirements are the numerator and the denominator have their degrees are the same. So if the numerator was second degree and the denominator was second degree, then you could do this. Okay. We typically don't do it unless the numerator and denominator both have a degree of 1, but you could. So I am going to do these pretty much the way you need to do them. When you're doing work, you need to, and that's why I'm doing them on paper today, because I want you to see kind of a pattern you go in. When you are doing these, you need to label what you're doing. Does that make sense? You can't just have an x equals 6 walking around. I need to know what it is. Got it? Okay, so the first thing we're going to do is long division. Now, if you go back to our standard form and look at it, k is going to be our quotient, isn't it? And don't we write a remainder over a divisor? Yeah, we do that. So that's what we're doing. We're finding our quotient and have a remainder over divisor. We are actually going to write it as k plus 1 over x minus h. And it doesn't matter if the k is in the front or the back. Does it? No. It just looks better when we're doing that. Okay, so what do I have to multiply x by to get 4? 4. And I'm not even going to put it above the x because I know that I'm done now, yes? But I have to come down here and multiply everything by -4, the opposite. These are some things people messed up on the last test. You have to do this right or it doesn't work. So I get -4x plus 12. Okay, so my quotient is 4. My remainder is positive, so plus remainder over the divisor. You see that? Now, there's some things we're going to add to this process that you weren't doing last week. Just 2. Okay, the first thing we are going to do is h. And I'm going to do h a little differently because right now you can see h is 3. Everyone can see h is 3? Okay. H is 3, but if x had a coefficient, meaning a number in front of it, you would have to do what we're going to do now, so I'm just going to show you. Does that make sense? So to find h, you do x minus 3 equals 0. That is the denominator set equal to 0. Because h finds my vertical asymptote. Well, that happened when I divided by 0 last week, didn't it? So if I set the denominator equal to 0, is that finding out what makes the denominator 0? Yes. So I get x equals what? 3, which is also my h. Okay? So h affects the what? Vertical asymptote. And you'll notice if you ever see my work, I underline what I'm doing so I know this is the work for that. And when I do the next thing, that's the work for that. Okay? So my h is going to give me my vertical asymptote, yes? Originally, my vertical asymptote was x equals 0. Now it is going to be what? X equals 3. Now, you do not have to do this, but should you know that the reciprocal parent function is at 0? Yes. And would that help you remember that? Yes. Okay.
Will it always start at 0?
Yes, the parent function always was 0, and we moved it from there. The next thing we did was what? K. The horizontal, so we have to identify K, correct? Okay. K. So K is just what? 4. Because I did. What? Does it matter? No. Doesn't it look, I think it looks weird to have a +4 after a fraction. Don't you? Does it matter?
I think you put it in the
That would matter. Okay, what does K give me?
Your horizontal.
My horizontal asymptote. So it was y equals 0. Now what is it? Y equals 4. So here's the new thing we're going to do. What does that stand for? X-intercept. So we're going to start out with x-intercept doing what you really do, and then we're going to shortcut it because it's going to always happen. Okay, so an x-intercept, I always do my work like around and then my graph. That's just how I do it. I don't care how you do it. But if you do it this way, you probably can get like 3 graphs to a side of a paper. If you kind of just goes around it. So when I hit the x-axis, what's my y?
0.
It's always going to be 0. No matter what equation or function or type of function I give you, if you want an x-intercept, you just set it equal to 0, correct? Ethan, can you put your mask on, please? So 0 equals, and I'm going to go back to the original function, not the divided function. It's just easier that way. Okay, so I need to solve this for x, correct? Well, first thing I would do is multiply for the denominator, right? Well, 0 times the denominator is going to give me what? 0. Is that going to happen every single time? No matter what my denominator is, isn't it?
Yeah.
So could I really just set the numerator equal to 0? Because that's what I'm going to have, isn't it? Yes. But technically you're setting the entire equation equal to 0. Just the denominator is always going to 0 out when you multiply it over, isn't it? Okay, so what does x equal? No.
X. That's not defined. 0. I thought you said what 0 equals. I realized that doesn't make sense now.
Okay, this is multiplication. I have to divide. Heard about every answer possible but 0. Okay, so x equals 0 and y was 0, so my x-intercept is what? 0, 0. X-intercept has to be written as a point. Is it not a point on a graph? Okay, well if I made you find the x-intercept, I'm probably going to make you find the what?
Y-intercept.
How do I find a y-intercept? Plug 0 in for x, because on the y-axis, what is the 0 always? What is the x? 0. Okay, so again, go back to the original. You don't have to, but it's more condensed and easier to put into. Okay, so then I have 4 times 0 over 0 minus 3, which is all going to give me what? 0. Now, guys, question for you. If 0, 0 was my x-intercept, what does my y-intercept have to be? 0, 0. Every time. Now, we won't, but when you do these next year with me, we will have 5 or 6, hopefully not, at least 2 or 3, sometimes 4 x-intercepts. So one of your x-intercepts has to be 0, 0 if your y-intercept is 0, 0. But if this is a function, it has to pass the vertical line test, right? So how many y-intercepts can it only have? 1. Okay? So if I would get 0, 0 for x and not for y, I would know there was a problem, correct? If I got it for y and not for at least one of my x's, would I know there's a problem? Yes. Now, you're only going to have one x-intercept. What was another thing we did last week? We haven't done yet. Domain and range. And where does the domain come from? The vertical. So x cannot be what? And it can't be 3 because I can't divide by 3, and isn't that how we calculated our h? Yes. And our range, where does it come from? Horizontal asymptote. So y such that y is not equal to 4. And we could have done domain right after we did vertical asymptote, correct? And we could have done range right after we did horizontal. But you will be doing h, vertical asymptote, k, horizontal asymptote, x-intercept, y-intercept, domain, range, and graph. I don't care what your instructions tell you, that is what you're doing today. Got it?
Yay.
You see the problem, you don't read the instructions, you do what I told you right here in class. Got me?
Okay.
Okay, so now what? How do I graph this?
Now,
Put a dot at 0, 0 and hope for the best.
Yeah, probably a little bit more than that. Vertical asymptote is at 3, right?
When do you use the like slash one to do?
If it like lands on the x or y axis because you can't see, does that make sense?
Yeah.
Now you do not have to label if you're counting by ones. Got it?
with my
If you jump to 6, please quit doing that. Thank you. Then you have to write a 6 on there. Next year you'll have some that are like 20, so you'll just put a slash in 20. Okay, now we know it has to go through here, yes? And it has to go near these asymptotes, so what does it have to do?
Looks like that.
And next year I will make you do interval analysis, but I'm not going to make you do that this time. And we know the shape of just the basic reciprocal function, which we're doing. Rational functions get more involved, but we're just doing basic ones. Now, could this piece ever be here?
but yeah,
If I wrote it here and not there, I would not have a function, would I?
no.
No, because it wouldn't pass the vertical line test. Now, is there a y-intercept here? Is there an open door in that y-axis up here? No. So could I even be here? No, because I've got to get to those asymptotes, don't I? Why can't I be here? Now, I could be here and still be a function, correct? But there's no what right here?
Dotted line.
There's no x-intercept. If there's no x-intercept, can I get through here?
No.
No. Okay. Again. F of x hopefully you're not working in pen, is 6x minus 1 over 2x plus 1. I just realized I was working in pen.
Wow, who does that?
Yeah, wow.
At least if I was using an erasable pen, it would be good.
You.
That's hard to bring one thing.
Mine do. Mine work good.
But look how good that looks.
Okay. What do I do first?
Long.
Long division. Are you doing it?
Yeah.
Okay.
I'm in the middle of right.
Okay, did you get 3 minus 4 over 2x plus 1?
Yeah, that's what I switched them up.
Okay, what? You switched what up?
I switched the 1 to 3. Why?
Okay, what is the 3? 3 is the quotient, 4 is the remainder. That's how we wrote remainders when we did long division at the very first, right? Remainder over the divisor?
Yeah.
Yep. Yeah, on the computer. I like showed you very first and then showed you how to fix it because it's gross. It's gross unless you have to graph it, right? Okay, so now what?
Now
H.
we gotta do-
H. How do I find H?
By looking at it and knowing that by setting something equal, by setting the denominator equal to 0.
The denominator equal to 0. Guys, H is what x cannot be. What can we not divide by? 0. So setting it equal to 0 will tell me what it can't be, won't it? Okay, I would have to subtract 1, divide by 2. So x equals negative 1/2. So that means that also equals H. So this graph is going to go what direction? Down. You don't have to do that. I just did it. Okay, now what?
Now we can find K.
Vertical asymptote. And guys, you could do H, then K, then vertical, then horizontal. That's all up to you, okay? But they all need to be done. So I would group them I've kind of forgotten how they flow, haven't I? Okay, vertical asymptote was where?
0.
0, and now it is at negative 1/2. Do you want to do domain right now since we're doing everything that involves domain?
Yeah.
Okay. So, well, maybe we'll just change this to our order. We can do that, right? So domain is x such that x can equal what? Negative 1/2. Sometimes this helps people to not forget to do domain and range. Okay. Now what? Okay. And if you're labeling your work, can you go back and see exactly what order you did this in?
Mhm.
Yes. Okay, what's K?
K is set of 4 to
The whole number over there.
K is the whole number. So that means it's going to go up, right? Okay, then what else? What's next? Horizontal. And where was at what?
0.
And now it is at
3.
3. Now, you guys notice how I put an equal with an arrow here? Because y equals 0 is not equal to y equals 3, is it? Okay, we do that when we mean goes to or changes to, something like that. Okay,
I'm gonna do
the range. Good job. Y such that y does not equal 3. Now, fifth hour loves interval notation. You guys seem like you're all good on set notation. You all good on set notation? I
I
think it's.
used to only use the other
I think this is just easier. It just is. It's cleaner. Could you put your feet down, sir? Thank you. Now what?
one. Now I'm gonna do the
X-intercept.
X-intercept, and make sure you're labeling them. You should be able to know what your work is doing just the same as I do. How do I find every x-intercept?
0 for 1.
0 for y. So 0 equals 6x minus 1 over 2x plus 1. But I'm going to show you once again what's going to happen when I multiply my denominator over.
We're gonna do
It's just gonna go away.
It's going to go to 0 because 0 times anything is 0. And that is going to happen every time, guys. Every single time. So now what? Add 1 and divide by 6. So x is going to equal 1/6. So I have 1/6, 0. Somebody last hour said, how do you graph that? And it wasn't 1/6, it was something else. I'm like, less than 1, almost 0, right? It doesn't have to be exact. That's why you write the point over here, so I know exactly what it is. You just have to get me close. Now, if you put it at a half, are you going to be wrong?
No.
Yes, it's a 1/6. Now, if it's a 1/3 and it looks like at a half, are you going to be wrong?
Yeah.
Not really, because that's close. But it's not a 1/6. Okay, what's next?
Y-intercept.
Y-intercept. How do I find that?
You put 0 for x.
So back into the original function again.
Mm-hmm.
So it's going to be 6 times 0 minus 1 over 2 times 0 plus 1, which is all going to be just
-1.
-1. Because it'd be -1 over 1, right?
Yeah.
So 0, -1. Now we got to graph it. Now, guys, if you go up, don't put your x-axis in the middle. Where should you put it? Toward the bottom. To the side. I don't think you put it to the side. Remember your arrows on your positive at least, right?
Yeah.
Okay, so -1/2. So if this is 1, 1/2 would be like right there. And then what do we got? 3?
Yeah.
I will tell you it will help you to get about the same scale on your X's and Y's if you can try to do that. Does that make sense what I'm saying? Okay, and again, these asymptotes are just dotted lines. They're imaginary, right?
Yep.
Okay, so 1/6 and -1.
Yeah.
So can you guys see how this graph has to go?
Yeah. It goes like that over there, and it does it on the other one too.
It has to go here. Now, could it possibly be right over here in that new third quadrant?
Well, it's not.
Could it be?
Well, not if it's going that way, because then it's going to run into it.
Well, couldn't it do this?
Yeah, but there's not an x.
But there's not an x-intercept. But
Yeah.
could it do that? Could it be up here?
Might be more work than
Could it be up here?
No.
Why not?
Because it has y across the y.
It wouldn't, and it wouldn't be a function. This says it's a function, right?
that. Yep.
If you put it there, is it a function?
No.
Nope. Now, if you did all the work and that's where it went, ooh, that was a horrible curve, then you would say you are not a function. Pretty? One more. I'm just trying to give you kind of examples of the division and stuff that might come up. Okay? So this one's going to be the one. You guys want to start it on your own?
Sure.
Okay, f of x equals x over 2x minus 5. Now, I just made this one up, so
It's maybe like -600 times.
probably not. But close.
No.
Already done.
Wow, really?
What'd I do to you?
You do half.
Here.
You can do half of it, can't you?
We can, but
And you will.
So 5 will be like
dark.
2.5.
No, half.
Immediately
Half of 5. 2.5.
Oh, no, 5 halves.
Good enough.
Got it.
No, just using 0. 35 now.
Okay, so then I'm going to have what? Negative x plus 5/2.
Yup.
So, how's that going to write out?
So 5 over 2.
A lot nicer
Oh
if
my
you just wrote
God.
2.5.
1/2. No, it wouldn't, because you can't put 2.5 in a fraction.
It would just be 0.5.
No, you cannot put a decimal in a fraction.
If you wanted it. Oh, it might not be right, but you can do it.
Okay,
9
5 over
over
2
4.
is
now, this is 5 over 2, correct? Okay, so it is 5 over 2 times 2x minus 5. Because it was 5 over 2, wasn't it? Now, we're not going to leave it like that, are we?
Yeah.
Yeah, we are.
You're gonna distribute it.
We're going to distribute it. Well, if next time I'm going to give you a problem like that, and then you'll be whining about it.
Oh, I'm gonna whine no matter what.
Yeah, 4x minus
So 4x minus 10. See? Doesn't even look that bad, does it?
Yeah, it does. No, but it's cool.
So we got the hard part done.
10. Yeah.
Maybe.
No.
You want to try to start it?
No.
Yes, I do.
Shut.
How about I give you a 2-minute head start?
You'll still do that.
You got 2 examples to look at.
They're not right. This is
You're not going to be able to look in the book. You're not going to be able to look in the book because they don't do it the same way I do.
So you're really trying to hurt us.
No. Trying to give you a more practical way.
You know the way.
Those stupid fractions.
I didn't even
I
know
know how to do it. 2 minutes is up.
Just a minute.
Oh,
I know. I think I'm going to jump in. I'm going to jump in.
well, there you have it. Yeah, you might do it.
Do you want us to keep with the fraction?
Yes.
That was fine.
It shows you how bad
So after you guys got out of the HKR, all that, it was no more fractions, right? How'd it go?
I got it
Pretty
right.
simple.
Can I take a picture of this?
No.
Um,
No.
Evan.
I'll take your phone till the end of the day,
I
though.
need that work.
I'll put it back. You can also go watch the video or take notes, Evan.
She always takes a video.
That's why she didn't know what she did.
Okay. So after we got out of the division and the fractions, and they didn't cause us too much problems, did they? No. Now, like I said, I just made that one up, but you will have one. I can multiply anything by any constant and get it what I want it to be. How could I make 7 into 3?
3 sevenths.
3 sevenths. Now, the way you figure that out, if you don't know, you say 7 times what gives me 3?
3 sevenths.
3 sevenths. Okay,
My favorite number.
your favorite number. Any questions, guys?
I thought you said that we couldn't say what you said.
You thought what, huh?
You said 7x. What could you 7x and 53? You said that. You couldn't say that.
What?
You said that a lot.
Okay, I said that. Oh, because we were doing, what were we doing? Something. Oh, was it synthetic? No, it wasn't synthetic. It was when we were doing Gauss-Jordan elimination. You guys were saying, like, the wrong thing. You were saying it wrong. Okay, so you have just 6 problems today. They're going to take a minute, but they shouldn't take you forever in a day, should they?
I only count
5?
5.
Yep, 5. Sorry. I could add one for you. Evan wants one more.
I gotta get a year.
I don't believe I said that.